So we are discussing heat and temperature. So first is heat. It is a form of energy and it flows from hotter body to a cooler body, or from a body of higher temperature to a body of lower temperature. Very easy to understand, very easy to solve. Okay? To a body of lower temperature. Now, the question arises, what is temperature? Anybody? Shreya, what is temperature?
Measurement of heat.
Heat temperature is?
Measurement of degree of hotness.
Is the measure of? Yes. Is the measure of?
Degree of hotness or coldness of the body.
Degree of hotness or coolness of a body. ठीक है? And it is measured in terms of Celsius, Kelvin, Fahrenheit. ठीक है? So it is measured in terms of Celsius, Kelvin, Fahrenheit, and so on, right? So the thing arises, the question arises, how this temperature is measured? Anybody? How do we measure the temperature?
So by measuring scales.
By?
Measuring scales. Celsius, Fahrenheit, Kelvin.
Nee. What do we measure? We do measure temperature, but how?
So using a thermometer?
Yeah, very good. So we measure temperature. Temperature is measured using a thermometer. ठीक है? Now, how do you construct a thermometer? Now, this is the most important thing, all of you. How do you construct a thermometer?
So by deciding a specific scale.
देखो बहुत स्केल बनाने से पहले
Sir,
हाँ बोलो
we
बोलो
know that water boils at a certain temperature
okay
and freezes at a certain temperature. So 0 degrees Celsius and 100 degrees Celsius respectively. तो उससे उसमें थर्मामीटर डाल के ऐसा कुछ.
see that is you're defining a scale, right? You're not
Right.
constructing a thermometer. Scale तो बाद में
Yeah.
define होगा ना
By
पहले तो
deciding the number of intervals and
okay. See, every object, see, a thermometer is what you will do is you measure the change. It can be a physical change or a chemical change, right? In an object, to define the state of to define the measure of or to measure the temperature of that object, right? You actually measure. क्या करते हो आप? You actually measure the change in physical or chemical property of a substance to identify or to calibrate or to measure the heat content in that object. Yes or no? For example, there are two types of parameters for every object, right? One is physical. One of the parameters is physical. So what are the physical parameters which change with temperature, all of you? Name some physical parameters which change with temperature. Sorry, physical parameters which change with temperature or physical properties.
state of matter. The phase or state.
चलो एक एक करके कौन है नया बच्चा आज? पूर्वी दवे, बेटा तेरा नाम क्या है असली? The one with the name of Purvi Dave. Please tell me your name. कहाँ चला गया है बच्चा? तुम्हारा नाम बोलो सही। नहीं नहीं, तुम्हारा नाम। अरे यहाँ चैट पे लिख दे बेटा। श्रेय, हाँ ये ठीक है। तो श्रेय, चलो श्रेय ठीक। सार्थक, तेरा कैमरा बंद क्यों है?
सर अभी कर रहा हूँ।
चलो, सो फिजिकल प्रॉपर्टीज में देयर विल बी लेंथ which change with temperature, there can be volume which change with temperature, there can be pressure which change with temperature. Yes or no?
Yes, sir.
We can actually make a thermometer based on this. We can actually make a scale based on this, right? They change with temperature. It can be area. So these are physical properties. Chemical properties. Chemical properties में क्या होता है बताओ? Which change with temperature. There can be many things, right? Color. और क्या होता है?
सॉल्युबिलिटी।
कलर भी पर फिजिकल हो जाता है एक्चुअली। कलर चेंजेस बिकॉज ऑफ केमिकल चेंज जो होगा, स्टेट, ये सब पर जब तक चेंज
सर
होता है।
स्टेट केमिकल होगा।
सॉरी,
सर स्टेट भी तो फिजिकली होगा ना, वो कैसे केमिकल होगा?
एक्चुअली ये इसको बोल नहीं सकते। हाँ ये सब, ये जो है ना, ये तुम्हारा केमिकल प्रॉपर्टीज को वी कैन नॉट मेजर विथ रिस्पेक्ट टू चेंज इन टेम्परेचर, राइट? So to construct a thermometer, we need, out of these two properties, we need only physical properties may change. Understood all of you? We don't see a change in chemical properties with respect to temperature to construct a thermometer. We see the change in physical properties. All of you understood this or not?
Yes, sir.
Yes, sir.
This is the first thing which we should remember. So physical properties are essentially required to observe the change in temperature, right? So now suppose karo I have taken this physical quantity, length. Okay? Pay attention है, मैं करने क्या जा रहा हूं यहाँ, देखो ध्यान से। लेंथ में मैंने I chose this physical property and identified three substances, S1, S2, S3, and this is the change in temperature. I made these four columns. So the physical property which I chose was length, and I made these four columns where I'm seeing I have chosen three different substances for length only, right? Where I will plot the with respect to change in 1 degree Celsius change in temperature. So delta T is 1 degree Celsius. ठीक है? For all this. So length was per degree change, the length was changing exponentially with temperature. Let's say it is cube, right? L1 is changing with delta T whole power 3. L2 is changing e power delta T, right? And the length of the third element is directly proportional to change in temperature. All of you tell me which one of these three you will choose to make a scale.
सर S3।
All of you.
S3।
Obviously S3, because L3 is directly proportional to delta T. So we will write the proportionality constant as some constant A into delta T, and this becomes a linear equation. And this scale will be easier to plot. Yes or no, all of you?
Yes, sir. Yes, sir.
Yes, sir.
Yes.
ए बैकग्राउंड में आवाज तो नहीं आ रही तुम लोग को?
नहीं
नो
सर।
सर।
No, sir.
बहुत बढ़िया,
नो सर।
ठीक है। सो L3 is equal to A delta T, right? So the first condition to construct a thermometer is we have to identify a parameter which is linearly changing with length. Clearly? Clear hai sabko ye?
Yes, sir.
Now, for every degree change in temperature, 4 degrees, this is the length. अच्छा चलो यहां तक तो ठीक है. So now what I do is I have again I have three substances, three different categories of those substances which are varying linearly with the length of which is linearly changing with temperature. ठीक है? So for every degree change in temperature, this is L1, this is L2, this is L3. इतना ही रखते हैं अभी फिलहाल के लिए, ज्यादा नहीं करना. ठीक है? L1 is changing 1 mm per degree Celsius. ठीक है? L1 is changing 1 millimeter per degree Celsius. L2 is changing 2 meters per degree Celsius. And L3 is changing at least 20 meters per degree Celsius. Which one of these three? इसको 1 millimeter, 1 meter, इसको 2 meter की जगह 2 centimeter कर दो. Which one of these three you will choose to make a thermometer? All of them are varying linearly with.
First one.
Yes, sir. First one.
So second one.
Second one, first one, है ना? एक बात बताओ, तुमको टेम्परेचर बुखार कब लगने लगता है? 1 डिग्री ज्यादा भी होता है तो बुखार लग जाता है, लगता है या नहीं लगता है? ऑल ऑफ यू.
Yes, sir.
हाँ सर।
इसको
सर 1 डिग्री फ़ारेनहाइट से ही हो जाता है.
सॉरी,
सब 1 डिग्री फ़ारेनहाइट से ही बुखार हो जाता है.
है ना? 1 डिग्री
Yes.
फ़ारेनहाइट में यू फील दैट यू हैव टेम्परेचर एंड यू हैव फीवर, राइट? सो
Yes, sir.
में बोलते हैं 104 डिग्री सेल्सियस अगर पहुंचा या फ़ारेनहाइट पहुंचा, सॉरी फ़ारेनहाइट नॉट सेल्सियस, तो बहुत सीवियर बुखार है बोलते हैं ना, इट डैमेजेस योर ब्रेन. तो ये 0.1 mm लिया मैंने. वी आर टेकिंग अ 0.1 mm per degree Celsius change length from 98 degree लेते for the sake of calculation, from 98 degree Fahrenheit to 104 degree Fahrenheit. How many Celsius, how many millimeter will change?
0.6.
0.6.
Will you be able to see it in a thermometer?
No.
जब तक तुमको पता
No,
चलेगा
sir.
इसमें क्या होगा,
No, sir.
है ना? गड़बड़ हो चुकी होगी. So this is not advisable. So this is not sensitive to change in temperature. L1 is not sensitive to change in temperature. I hope all of you understood it.
Yes, sir.
But what about this one? इसमें दिख रहा है कि it is changing, right? For 1 degree Celsius, you can see a change of 2 centimeter in the length of the material used, right? So that is how you, इसमें क्या होगा, पूरे मोहल्ले को पता चल जाएगा तुम्हें आधा डिग्री भी बुखार बढ़ेगा तो, हाँ या ना? 10 मीटर का थर्मामीटर लेके आओगे क्या? नहीं. तो यूजेबिलिटी, पोर्टेबिलिटी. यूजेबिलिटी में क्या होता है? फर्स्ट इज इट इज रीडेबल and portable, right? So the three most important things are the length, the parameter should vary linearly with temperature, And then the thermometer should be, the scale of the thermometer should be readable and the thermometer should be portable. I hope all of you understood this. This is how we construct a thermometer. Yes or no?
Yes, sir.
Yes,
Yes.
sir.
ठीक है. So while constructing a thermometer, the thing which you should keep in mind is, number one is physical property. ठीक है. While constructing a thermometer, the first property which we look for is physical property or linearly varying physical property with respect to change in temperature. This is what we need to look for. Second, the property should be moderately sensitive. Not very high, not very low. ठीक है? I hope all of you understood these two
Yes, sir.
statements. Anybody is having any doubt? Param, समझ आ रहा है बेटा?
Yes, sir.
ठीक है. So this was what we have. और श्रेय समझ आ रहा है बेटा तुमको? You can type. ठीक है. Now comes the next thing. Thermometer तो बन गया. अब how to make a scale. ठीक है. स्केल बनाने के लिए क्या करना होगा? तो बहुत सिंपल है. We identify a parameter, let's call it as length L, and we assume that it is linearly varying with temperature. All of you please pay attention now. So these two are constants. A and B are constants, right? So the reference temperatures which we use to make a scale is, reference temperature which we use to make a scale is T is equal to 0 degrees Celsius, that is ice point or freezing point, and T is equal to, this is T1, this is T2, this is 100 degrees Celsius, this is boiling point of water. I hope all of you understood this. Yes or no? So
Yes, sir.
Yes, sir.
we now want to make a scale, right? We now want to make a scale. कैसे बनाएंगे देखो ध्यान से. So we will measure the length of this property at L1 and L2 measure किया for ice point and boiling point of water, right? So L1 L2 measure कर लिया for at that particular temperature. Now we have to find values of A and B. So we have L1 is equal to A plus B T1. So T1 is what? 0 degrees. So substitute the value of T1 as 0. You get the value of A as L1. I hope all of you understood this. Yes or no?
Yes, sir.
So A is equal to L1. Now what about L2? L2 is L1 plus B into T1 is how much? 100 degrees Celsius, right? I'll just remove this degree Celsius sign here just for the sake of convenience. So we have B is equal to L2 minus L1 upon 100. Clear hai? Minus 0 degrees. Hello?
Yes.
Because I'm
Yes,
taking
sir.
the reference temperature as T1, right? That is 0 degrees. Or you can write it as L2 minus L1 upon T2 minus T1. I hope all of you understood this. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Now what about
Yes,
the
sir.
length now? This length will now become L is equal to L1 plus B. What is that B? It's L2 minus L1 upon T2 minus T1 into 100 degrees Celsius. Right? Hello? Not 100.
Yes.
Not 100. My bad. This is not 100. This is T. This is some T. So the value of temperature for a given length is equal to what? L minus L1 into T2 minus T1 upon L2 minus L1. L minus L1 into T2 minus T1 upon L2 minus L1. This is how we find, for a given value of length, we find the temperature. If you want to write it in terms of these temperatures, just substitute the values here, you get the value. It will be T is equal to L minus L1 upon L2 minus L1 into 100 into 100 degrees Celsius is temperature T. I hope all of you understood this. Yes or no? In
Yes.
place of length, any other parameter can be there. Resistance हो सकता है, volume हो सकता है, it can be pressure, it can be any other thing, which varies linearly with temperature. That is the case. I hope all of you understood how to make a scale of a thermometer. Yes or no?
Yes.
Yes,
Yes,
sir.
sir.
परम समझ आया बेटा?
Yes, sir.
Okay. Copy it quickly. All of you note it and just let me know if you have noted it. I am just
So
floating a
just a question.
पूछो.
The L2 minus L1 is the scale for the new thermometer, right?
L2 minus L2 and L1 are two different constants of length at reference temperatures.
So sir, what is L?
L is, अरे तुमने स्केल बना लिया 0 से 100 तक का?
Okay, sir.
In thermometer, you found that now the length is lying between some value L is there, right? Suppose L1 was 1 centimeter. L2 is say 50 centimeter. Okay. Now the length at a given temperature, you don't know the temperature now. At a given temperature, the length is showing as 20 centimeter. At some day, the length is showing as 20 centimeter. So what will be the corresponding temperature to it? That is how you measure the temperature. Understood or not?
Oh, okay, sir. Okay, sir.
Likho. For a corresponding length, what is the temperature? Okay, but when L1 and L2 are given to you.
All
When
right, sir.
T2 is known to you. Please make a note of it. And answer the poll, huh? लिखो भाई फटाफट जल्दी लिखो खत्म करो इसको Done, all of you?
Yes, sir.
Yes, sir.
Okay, most of you are done. So let's move ahead. Chalo. So this was how to make a temperature, how to make a thermometer and its scale. Okay. Now, ये सब नहीं लिखना है तुमको. Now, let's learn about thermal expansions. Okay. Thermal expansions. Thermal expansion में, there are 3 different types of thermal expansions which we are interested in as of now. Right? The first one is linear expansion. So at temperature T naught, length is L naught, area is A naught, volume is V naught, and density is D naught. And of course, mass remains same, which is M. Right? Mass never changes with change in temperature. Okay. So this is what are the initial parameters, the physical parameters, right? This is length. You want me to write it or you can understand it? Length, area, लिख ही देता हूं, बात का झंझट खत्म. Volume, density, and mass. Okay.
Yes, sir.
At temperature T, length is L, area is A, volume is V, mass is M, and density is D. Mass में कोई change नहीं होता है. Okay. Now, for linear expansion, please pay attention. Huh? For linear expansion, it's very simple. For linear expansion, the change in length is L naught alpha delta T. Right? Where what is alpha? Alpha is thermal coefficient of linear expansion. ठीक है? It is coefficient, thermal coefficient for linear expansion. Okay. So length L at any temperature T, of course, T is greater than T, right? So L at any temperature T is L naught plus L naught alpha delta T, or L naught times 1 plus alpha delta T. This is L. I hope all of you understood it. Yes or no? There is one more thing which I wanted to add here, that is resistance. R naught है ये और ये R है. ठीक है? This is for linear expansion. Anybody is having any challenge in this, please ask. Hello.
No, sir.
For aerial और surface expansion और superficial expansion भी बोलते हैं इसको, right? For aerial or surface expansion or superficial expansion, we have change in area is equal to A naught beta delta T. Right? What is this beta? This is thermal coefficient of aerial expansion. Thermal coefficient for aerial expansion. Okay. So area A at any temperature T is given as A naught times 1 plus beta delta T. This is again a very important expression to remember. Now the next one is for cubical expansion or volume expansion, right? For cubical or volume expansion, this is delta V is equal to V naught gamma delta T. This gamma is how much? What is gamma? Gamma is thermal coefficient of for thermal coefficient for cubical expansion. Right? So V is equal to V naught times 1 plus gamma delta T. I hope all of you understood this. Yes or no?
Yes, sir.
यस सर
Yes, sir.
सर
Yes,
एक
sir.
सेकेंड वो आर रेडियस है क्या
नहीं 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 रेजिस्टेंस है बेटा.
ओके
This is resistance.
ओके
ठीक है. इतना नोट करो फिर आगे चलते हैं. वी विल डिस्कस अबाउट आर नॉट एंड डी नॉट. आर एंड डी. नोट.
Yes, sir.
2 minutes.
सॉरी.
2 minutes.
हाँ हाँ करो. श्रेय समझ आ रहा है बेटा? श्रेय. हाँ, delta T is always written in positive sign because T, we are increasing the temperature, right? If the temperature decreases, then delta T will be negative. What is delta? Delta T is final temperature minus initial temperature. Okay, Shrey? If the temperature falls, then it becomes negative. If it rises, the temperature delta T becomes positive. Please be quick. But don't miss also, हाँ? मतलब गलत कुछ नहीं लिखना बेटा. Please be quick, be quick. Please note quickly. There are a few of you who are left. Last 1 minute to go. So I hope all of you have understood this particular part of it. Then comes, let's see the resistance for the part, okay? See, for resistance, okay? For change in resistance, see what happens here is delta R is equal to R naught alpha delta T. Now this alpha is nothing but thermal coefficient of resistivity. Thermal coefficient of resistance, right? So the resistance R will be what? It will be R naught times 1 plus alpha delta T. So you can see here that when the conductor, see alpha is positive. All of you please remember, alpha is positive for conductors. So that means the resistance of a conductor increases. The resistance of a conductor increases when the temperature rises, right? Alpha is negative for insulators and semiconductors. So please remember this. Alpha is negative for insulators and semiconductors. All of you please remember it, right? So this is all about alpha. Now let's discuss for density, for variation in density. Please pay attention. Huh? ये बहुत important है बेटा. The entire process of heat transfer, which is convection, depends on this variation in density. So for variation in density, see what happens. How many of you have boiled water for yourself in a gas burner? How many of you have
Yes,
done?
sir.
Yeah, है ना? So when you boil the water, right? In the initial stages of it, after hardly 15-30 seconds, if you can dip your finger in that, it doesn't become that hot. You can see that the upper layer of the water becomes hot, but the bottom layer doesn't become hot, right? Water. So this is because the hotter molecules are actually moving up on the surface and the cooler molecules are going down. So this is a process of convection which happens, right? So for variation density, what happens here is mass is always a constant. So density, mass upon density is volume. So M is what? Volume into density, Vd. So V naught into D naught is equal to V into D. Yes or no? At any temperature and at temperature T naught. All of you, please say yes or no.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Now this is V naught D naught. For V at any temperature T is, we have just now derived it. It's V naught 1 plus gamma delta T into D, right? So you can now see here that D is what? D naught. This V naught cancels out. D naught upon 1 plus gamma delta T. Yes or no? You can see here, since gamma is positive, so density with increase in temperature, density is decreasing, right? So if, please pay attention, if gamma delta T is very small as compared to 1, then isko you can write it as D naught times 1 plus gamma delta T power minus 1. If gamma delta T is very small as compared to 1, then D can be approximated as, not equal to, it can be approximated as D naught times 1 minus gamma delta T. But this equation is only valid when this case is valid, right? They are interrelated. If this doesn't suits, if this is not equal, or if gamma delta t is not very small as compared to 1, then this is not valid. I hope all of you understood it. Yes or no?
Yes, sir.
Is this
Yes.
one?
सर नेग्लेक्ट होता है क्या फिर वो?
कौन बेटा?
if it's very less
ये
compared to 1,
नेग्लेक्ट नहीं हो रहा है,
then
नेग्लेक्ट नहीं हो रहा है, ऐसा दिख रहा है ये. सी क्या होता है,
अच्छा.
I'll explain it to you. See, there is an expansion in maths. ठीक है, 1 plus x to the power n. So it says if x is very small as compared to 1, then 1 plus x to the power n is equal to 1 plus nx plus n into n minus 1 into x square upon 2 factorial plus n into n minus 1 into n minus 2 power x cube upon 3 factorial and so on. ठीक है? But since x is very small as compared to 1, therefore we can ignore higher powers of x except 1. Understood or not?
yes sir.
Yes, sir.
So from here we get 1 plus x to the power n can be approximated as 1 plus nx. So that's how we got that. This is why we are writing this as this, because this negative sign will be multiplied here. समझ आया
अच्छा.
श्रेया?
हाँ सर समझ आ गया.
All of you?
Yes, sir.
Got it.
Yes, sir.
Yes, sir.
Okay. Okay. Lonika, Vaidehi, Stuti, Shreya, तरुशिका. ठीक है, नोट करो. श्रेय समझ नहीं आए तो पूछना है बेटा, है ना? पहले इसको नोट कर लो. ठीक है, इस पेज को, एंड देन वी विल मूव टू दिस, देन राइट दिस कंडीशन.
सर ये अल्फा का कन्वेक्शन नहीं समझ आ रहा.
क्या क्या?
सर ये अल्फा का कन्वेंशन नहीं समझ आ रहा. साइन कन्वेंशन जो पॉजिटिव का.
अगर अल्फा की वैल्यू पॉजिटिव होती है कंडक्टर के लिए, तो उसमें रेजिस्टेंस इंक्रीज करता है टेम्परेचर के साथ. ठीक है.
यस.
और अल्फा की वैल्यू नेगेटिव होती है इंसुलेटर्स या सेमीकंडक्टर्स के लिए, उसमें टेम्परेचर के साथ रेजिस्टेंस डिक्रीज करता चला जाता है.
यस सर.
बस यही है.
ओके.
पॉजिटिव नेगेटिव है कब है? जब टेम्परेचर बढ़ता है. ठीक.
यस सर समझ आ गया.
हाँ, गुड. Yeah, it will be per degree Celsius or per Kelvin. अरे ये रेजिस्टेंस उसी का ही है, इलेक्ट्रिसिटी का ही है देवी, स्तुति जैन. ये इलेक्ट्रिकल रेजिस्टेंस की बात हो रही है.
ओके सर.
Noted, all of you? If you have noted it, answer the poll quickly. परम समझ आ रहा है बेटा?
Yes, sir.
ओके ओके डन. So, okay, most of you are done. Let's move ahead to, please note this one also. ठीक है, एक बार 2 फैक्टोरियल होता है या 2 होता है, बस मैं चेक कर लेता हूँ. बाकी तुम लोग ये बाकी नोट करो इसको. ठीक लिखा है मैंने.
सर ये 2 फैक्टोरियल ही होगा,
होगा होगा.
करेक्ट?
चलो, डन ऑल ऑफ यू with this part.
Yes, sir.
Please remember it. It's very important. Okay. Now comes क्या आता है एक यहाँ पर. हाँ. Now there is this relation between, all of you please pay attention. We have this relation between alpha, beta and gamma. देखो ध्यान से सुनो सब, all of you. What is area? Area has 2 dimensions of length. Yes or no?
Yes,
एक
sir.
dimension or no?
Yes, sir.
Yes, sir.
Volume has 3 dimensions of length. Right?
Yes, sir.
Yes, sir.
Volume has 3 dimensions of length and area has 2 dimensions of length. So ln of A is equal to what? 2 ln of L. And ln of V is equal to what? 3 ln of L, right? Now, differentiate this, you get delta A by A is equal to 2 delta L by L. Similarly, delta V by V, we are differentiating it, right? 3 delta L by, sorry, it's 3 delta L by L. Clear? Anybody is having any doubt in this?
No, sir.
No, sir.
Delta A is A beta delta T upon A. This is 2. Delta L is L alpha delta T for the same change in temperature, right? Upon L. Similarly, here it is V gamma delta T by T, sorry, by V is equal to 3 L alpha delta T upon L. This cancels out, delta T cancels out. Right? So beta is equal to 2 alpha and gamma is equal to 3 alpha. And so alpha is to beta is to gamma is equal to 1 is to 2 is to 3. I hope all of you understood this. Yes or no?
Yes,
Yes, sir.
Anybody is having any doubt in this derivation, please ask.
No.
कॉपी करो
Sir, we
जल्दी.
have differentiated both sides, right?
Yeah, I have differentiated it from both the sides. You know how to differentiate it or not?
Yes, sir, yes.
Any challenge?
No, sir.
Sure?
Yes, sir.
देख क्या होता है बेटा, d of ln of a by dx, dA करेगा ना इसको, तो ये क्या होगा, 1 by a होगा.
Yes, sir.
d of ln of a को you can write it as dA upon a. मैंने इसी dA को डेल्टा a लिख दिया, डेल्टा a by a, and this is delta of ln of a, right? ठीक है परम.
Yes, sir.
लिखो भाई जल्दी. Please answer the poll quickly if you are done with it. Please be quick. Chalo. So the last thing about this is errors. So what are actually errors in this? Pay attention. This is a common, widely, grossly misunderstood concept है ये, ठीक है? So error in this type of cases is, error is given as measured value minus true value. This is measured value and this is true value. ठीक है, इसको ऐसे याद रख लो, MTV म्यूजिक टेलीविजन होता है ना एक, हम लोग जब छोटे बच्चे थे तब आया था पहली बार ये. So this is how error is given. Now how we measure the error, right? Please pay attention. This is a line which is drawn on a paper. This is a line which is drawn on a paper, and these are the, okay, so this is the length of it. It starts here and it ends here, right? This is length AB of this line segment. Now here is a scale. ध्यान देना बेटा, ये बहुत important है, हाँ. This is a scale we have, and on this scale these are the markings on this scale, right? To measure the length. It starts from here. So थोड़ा सा तमीज से बना रहा हूं मैं ताकि तुम्हें समझ आए. ठीक है. Now pay attention, all of you. This is 0, 1, 2, 3, 4, 5. Now scale is sensitive to temperature, right? The line on the copy or the paper is not sensitive to it, right? All of you, yes or no? So these are, we are measuring in centimeters. ठीक है. So at temperature T is equal to T naught. This is at temperature T is equal to T naught. Length is how much? 5 centimeters, right? Now, let's say this was room temperature. T naught ki jagah, let's write this as room temperature. 25 degrees Celsius. Now, when the temperature increases, what will happen? Say temperature becomes 50 degrees Celsius. Now the length will change. The new length L1 will be what? The scale will expand, right? The scale will expand. See? है कि नहीं? So now the new length is what? Say 4 centimeters. Yes or no? All of you.
Yes, sir.
Yes, sir.
What
Yes,
is the
sir.
change now? What is the change? It's L1 minus L or L minus L1. What is the change? This one or this one? Which one should be the change?
Sir, L1 minus L.
L1 minus L.
Yes, very good. It's final reading minus initial reading, right? Final reading minus initial reading is the change. So how much is it? It's minus 1 centimeter. Right? So the error in this case is what? Error in this case is minus 1 centimeter. This is the error. So now if I want to find the true value, please pay attention. This is very important. And जब ये पेपर में आता है ना तो दिक्कत होती है. It is true value is measured value minus error. Right? So if error is given to you as positive or negative value, substitute it like that only. Measured value is 4 centimeters. Minus of minus 1 gives me the true value. Yes or no?
Yes, sir.
So this is how the true value is measured if we know the measured value and the error. If the error is positive, how will it become positive? When the temperature will drop. देखो क्या होगा? When the temperature will drop, sorry. Suppose करो temperature drops to say कुछ कर लो at temperature T is equal to minus 10 degrees Celsius. मान लेते हैं, ठीक है. Length L becomes what? The measured length now becomes L2 is what? 7 centimeters. Right? This is the measured value now.
Yes, sir.
Okay. So the error in this case will be what? It will be L2 minus L, which is 2 centimeter here. So now the true value will be what? True value will be what? 7 minus 2. That is 5
5
centimeters.
centimeters.
I hope all of you understood this. Yes or no?
Yes,
Yes.
sir.
Yes,
Yes,
sir.
sir.
Chapo.
Yes, sir.
What did we put in measured value? Could you please tell again? 4 or 5? Measured value is ये तुम ओजस्व चंद्राकर क्या तुम यार कैसा बात करते हो यार तुम क्या मेजर किए बाबू बताओ जरा हेलो कहाँ
Yes, sir, like we put the value according to the original scale or the.
अरे ओरिजिनल स्केल ही नहीं बचा तो ओरिजिनल स्केल से कैसे वैल्यू आएगा तुम्हारा
Okay,
अभी
like I
इस केस
just.
में एक एक थांबा इस केस में क्या नंबर क्या वैल्यू आ रहा है
Oh, sir, in the previous one we took.
अरे ये जो सामने दिख रहा है बाबू सामने जो दिख रहा है बताओ
Oh, that is 7.
7 सेंटीमीटर दिखाई दे रहा है ना
Yes, sir.
ये ट्रू वैल्यू है कि मेजर्ड वैल्यू है
Measured value.
मेजर्ड वैल्यू है तुम नापे हो ना जी इसको इसी स्केल का उपयोग करके
Yes, sir.
फिर तो ये मेजर्ड वैल्यू है एरर कितना है इसमें 2 सेंटीमीटर 2 सेंटीमीटर का पॉजिटिव एरर तुमको गिवन था मान लेते हैं
Yes, sir.
प्लस 2 सेंटीमीटर का एरर इज गिवन टू यू तुमने निकाला नहीं है गिवन है
Yes, sir.
तो ट्रू वैल्यू क्या होगा 7 माइनस एरर
Yes, sir.
ठीक पर यहां पे हमने क्या था पहले से हमने एल वैल्यू निकाल रखा है ओरिजिनल वाला तो 5 था वो ये तुम्हें सिर्फ दिखा रहा था मैं कि कैसे तुम उसको substitute करोगे if it is positive error it will be substituted as positive value only if it is a negative error it will be substituted as negative value only
Got
but
it, sir.
to measure the true value the error will be given to you
Yes, sir.
understood लिखो भाई इसको
Thank you, sir.
So almost done. चलो good. तो आज तुम्हारे लिए काम है, सुनो ध्यान से. I have not taught you conversion of scales. I think all of you have done it in your 10th standard, so I'm not doing that. चलेगा ना?
हाँ सर.
Okay, sir.
इसका प्लीज स्क्रीनशॉट ले लो तो जल्दी से. पहले इसका ले लो, बेसिक डेफिनेशंस का. Although you have noted it, plus take a screenshot. This will help you remember it. Memorize it neatly. On a count of 3, 1, 2, 3. ठीक है? चलो. So now for this one. Take a screenshot. 1, 2, 3. Done. बहुत बढ़िया.
Yes, sir.
So now I am sharing. This is the book which you need to follow. For those of you who are preparing only for 11th standard exams, okay, there are a few of you who are preparing only for 11th standard exams. You need to do what I'll tell you what you need to do from this book, and then you need to focus on your NCERT textbook. Can see this? So this is the chapter which you need to learn. Hot and cold bodies, read it. ये सब पढ़ना है, ये सब पढ़ाया है मैंने तुम्हें, ठीक है? Constant volume gas thermometer, just look at the formulas and understand what is happening there. Ideal gas temperature scale, ideal gas equation क्या होता है, ये सब पढ़ रखा है तुमने, एक बार और पढ़ लेना इसको, ठीक है? Solve worked out examples, all of you. It is mandatory for all of you to solve worked out examples. Understood?
Yes, sir.
Whether you are preparing
Yes,
for
sir.
only your 11th standard exam or for your NEET or IIT, whatever exam you are preparing for. First, complete your solved examples, number 1. Then those of you who are preparing only for 11th standard exam, switch to NCERT textbook. And the rest of you, complete the chapter. You are preparing for
Yes.
whatever exams.
Okay sir.
Whatever exam you are preparing for, you have to complete this chapter from H.C. Verma. Whether it is NEET or IIT, it doesn't matter at all. श्रेय, समझ आया बेटा, नहीं आया तुमको? होमवर्क है तुम्हारे पास H.C. वर्मा? Concepts of Physics Part 2. You have that? Okay. मैं ना ग्रुप में I will, you are there in the WhatsApp group? हाँ, तो I'll send the PDF. Meanwhile, you order it. ठीक है? Param, do you have this book?
Yes, sir.
Second part?
सर अब तो जो आती है वो एक ही पार्ट आता है एचसी वर्मा को, उसमें सारे चैप्टर्स होते
नहीं, अभी भी 2 पार्ट आते हैं बेटा. ये 12th वाला है, चेक कर लेना, ठीक है?
हैं.
चेक
ओके
कर
सर, मैं
लेना.
चेक कर लूंगा एक बार.
का नाम का चैप्टर है, सिर्फ सॉल्व
हम्म,
एग्जाम्पल करना है और कुछ नहीं करना है. एंड स्विच टू एनसीईआरटी टेक्स्ट बुक.
ओके सर.
फोकसिंग ओनली ऑन 11th स्टैंडर्ड. अगर जेई करना है तो फिर यू हैव टू डू इट. ठीक है? चलो.
यस सर.
सो थैंक यू सो मच फॉर टुडे सेशन. बाय, गुड नाइट, टेक केयर.
Thank you sir.
Thank you.
Good
Thank you,
night,
sir. Good night.
sir. Thank you.
गुड नाइट.